Welcome back to part 2, density curves. Sorry about that. I changed some of my hot buttons and threw things up. So I'm going to go through this. Now remember, my class, you can do this in your own notebook. And then I'm going to go back and we're going to do that last little part of the previous page. And then we'll come back and finish this. So you've got 3 big ideas for the day. The first one is density curves. Make a line. Density curves are always above the x-axis. Why are they always above the x-axis? What are they measuring? Density curves measure data. If you're collecting data, either you have it, you have some, or you have none. You can't have negative data. So that's part of the reason there. Other thing too, your area is always going to equal 1. Why is it going to equal 1? What percentage is 1? It's going to equal 100%. That's why. You either have it, you have all the data, period, done. So if you ever get a density curve and they're asking you stuff about the height or the width or things like that, remember it's always going to equal 1. So for example, you could have a uniform density curve like this. Okay, so this is uniform. Why is it uniform? Because it's the same. And then, so it could start at 0, could go all the way through k. So if that's the case, what do I multiply k by to get it equal to 1? Okay, so your height then is going to equal 1 over k. Okay? I think you can see that. Yep. All right. Couple of things. Learning target number 2. What happens if you have other types of density curves related to the normal curve? So first of all, we could have symmetric. Symmetric, of course, and you guys are going to get used to really nicely drawing these things. Okay. Here, remember your mean equals your median. You could have a skewed right one. So we have skewed right, and that would look like this. So you'd have the big, and then it would be, whoa, way stretched out over here. Okay, and actually we should probably say this is approximately equal to. This is not going to be perfect. Welcome to statistics. And this one here, you're going to have the median is going to be bigger than, less than the mean. So remember your median is going to be here. And then you've got your mean, which we'll do it in 2 colors. So there's your median, here's your mean. And the last one then, we could obviously have skewed left. So you can have this big long run up and then, so again, there's my median. My mean is going to trail towards the outlier. So in this case here, my median is going to be larger than my mean. Now, is this the only types of density curves we can have? No. You can kind of have, you know, ones that look like M's and other things like that, but that's going to be the big ones there. Now for the big one. Okay, and this is going to be our 68, 95, 99.7 rule. Okay, why is that? Well, let me show you. So draw yourself a nice little normal curve here. We're going to put our mean down the middle. Mr. Hayes, that's not a perfect, yeah, I know, thank you. Actually, I should have said X bar. Actually, mu, white out, white out, white out, white out. Why am I not pausing? Hey, skip this part. Okay, well, I guess we're just going to live with it. I'm not going to run upstairs. So then right here, it's about an inflection point. It's going to be 1 standard deviation away. So I'm going to turn that sideways, actually. So I'm going to say, we're going to call this mu. So this would be mu plus theta. We'd have the same distance across over here. So that'd be mu plus 2 thetas. And we're going to have this one over here, mu plus 3. We can do the same thing over here, mu minus 2. And then mu minus 3 thetas. Interesting thing here. So again, this is on a normal curve. Okay. Within 1 standard deviation, we have 68% of your data. And it's equally the same, okay? So I've got 34% this direction, 34% that direction, okay? Within 2 standard deviations of the mean, I have 95% of my data. Again, ideal situations. How do I know it's ideal? Because I'm using the Greek letters. Okay, so that means that I would have 47.5% on one side, 47.5% on the other. So 34, so since this is going to be 47.5% above the mean, that means that I've got 34 here, so that means I've got another 13.5% here, and another 13.5% here. And then lastly, between 3 standard deviations, you are going to have 99.7% of your data. Why is it not 100? Well, because you're always going to have some sort of outliers hanging around. You got to have the Michael Jordans, the Babe Ruths, the Bill Gates, those types of people, okay? So that makes this then, this little spot right here, by the time I split that in half and then take away what I already have, that's going to give me here 2.35%. Of the data. And this side over here is 2.35% of the data, which leaves these two little tails here with a wonderfully whopping, or think of it this way, how much space do I have left? I have 0.3, split that in half. So 0.3 and a half is going to be 0.15%. Okay. So because of that, then we can start messing around with it. Now, truly, the way that I kind of mess around with it is that first hit, this is 50% on this side, 50% above this, okay? You know, I've got 68, and you can kind of mess around with that and cutting things in half. Now, how does that work? Let's go back to the previous page. Oh, by the way, just in case you were curious, there we go. Check that out. We're almost even. We've got over 12,000 rolls, and we're getting very, very close. Okay. So, anyway, moving back here. So down here, where are we at? Make sure we're on the screen. What percentage of the data is further than 2 standard deviations from the mean? Okay. So from there, we are looking at the stuff out here. It says within. Oh, up here, I missed one. Okay, so what percentage of the data is within 2 standard deviations of the mean? So if I were to color that, I would have this. I would have here 1, 2, 1, 2. I'm looking for all of this data here. Now, again, remember the rule. The rule says 68, 95, 99, 7. So we're looking at 95. So that'd be 95% of your data. So then the question becomes, what percent of the data is further out than those two? Well, if 95% of the data is within here, how much is on the outside on the wings? Well, 100 minus, because again, remember back over here, you always have 100% of the data. So that would give us 5%. What percentage of the data is greater than 1 standard deviation above the mean? So here, it says greater than. So you're looking here. So I've got this, right? The way that I think this through, instead of memorizing all these little bits here, it's important to know that, don't get me wrong, is that I've got 34% here. Why? Because I know that this is 68. So that's 34. This right here is going to be 50%, because remember, everything above the mean is 50. Minus their 34, and so that's going to get me 16% of my data. Unless, ooh, what percentage of the data is between z of -1 and z of 2? What does z mean? Yeah, z's are standard deviations. So again, if you're not sure, you can sketch this out. So here and here, so I know that this is 68, right? So this is going to mean that this side, which is z of -1, is going to be 34%. Why am I not doing the other side? Because the other side goes up to 2. So there's z equals 2. So up over here is 95% of the data, which means that, so this whole area here is 34. This whole area here is going to be half of that 95. So that's going to be 47.5%. So 34% plus 47.5% is equal to 81.5%. Oops, missed the half. There you go. Okay, you can't see that. Good. All right. And that's kind of what we're going to be having you do today. So down here in the Check Your Understanding, take a look at these, hit pause, do a couple of them, and we'll come right back. Hey, welcome to the longest part 2 that I think I've done. I know, blah, blah, blah. All right, so a couple of things. Let's take a look at this. Internet reaction time. So the height of the density curve must have. Well, so if we're starting here and here, right, how far is this? So think about this. It's coming down here. It's coming down here. So how long is this? Oh, that's 4. So if that's 4, what does this height have to be? Okay, because again, remember, this has to multiply out to become 1. So 4 times h is equal to 1, so you should come up with 1/4. So no matter what we're going to be doing from now on, that height is going to be 4. So since the area is equal to 1, height has to equal 1/4. About what percent of the time will the lights flash more than 3.7% of the seconds after that? So again, think about this. Where's 3.75 seconds? It's right about there, right? So if I'm looking for greater than 3.75, that equals what? That's from 3.75 to 5. Okay, so 5 minus 3. That's an arrow. Mr. Hayes, you need art lesson. Yeah, well. So 1.25. So then what you're going to do, so your area now is going to equal 1.25 times 1/4. What do you get? 0.3125. So percentage-wise, 31.25%. Yay! I know. Calculate and interpret the 38th percentile for this distribution. Now, 38th percentile, that means that, again, remember, it's the first 38% of what's going on. Now, we know that these are quarters, so this would be about 25%, this would be 50%. So we'd say, okay, that's 38%. So how do we work that backwards? Well, 0.38 is going to equal the distance times your height, right? So distance times 1/4. So you're just going to say, okay, distance is going to be that 38th percentile divided by 0.25. Take out your calculator. You have it. There it is, hiding underneath my notes. So you get a width of, hey, 1.52. Yay. So your width, or actually here my distance can be 1.52. Why am I pausing? You know who you are. Right. Now remember, that means that this is distance here, from here to here, is 1.52. You're measuring it from 1. So your time equals 1 plus the 1.52. So 2.52 seconds. So approximately 38% of the time. What are we talking about? Light bulbs, right? The light flashes at 2.52 seconds, or less. Distribution of heights of young women aged 18 to 24 is approximately normal, with a mean of 64.5 inches, standard deviation of 2.5. So sketch the normal curve and write it out. So when they ask you to sketch a normal curve here again, there you go. Mean's in the middle. So since the mean is in the middle, that's going to be my 64.5. And again, the inflection point is kind of where you go from concave to convex. So right about there. So that means that we are 2.5 inches from that. So we're going to go up to 67. We're going to go down to 62. We're going to hit it about the same distance again. And then go up again, so that's going to be 69.5. We can go down, so that's going to be, what, 59.5. And then from 3 standard deviations down, you're going to go up, you're going to go right about here, so that's going to be 72. And then you're going to go down, and that's going to be, what, 57. And then there's some couple percentage questions about what percent of young women have heights less than 69.5. Again, if it's me, 68, 95, right? So my question is here, how much is that part? Because all of this is 1, okay? So you can either look back up here and say, okay, what are the parts? Well, okay, over 2, I've got 2.35 and 0.15. I would be perfectly honest. This is 95. This is 95. I know that. Where we're going. So it says less than that. So if this is 95% runs from here to here, that means I know I have 5% over here. So that means I have to have 2.5% over here and 2.5% over here. So I can either add these up and get 97.5. I could go 1 minus 2.5. So I could go 2.5 plus 95% and get 97.5. I could do 100 minus 2.5 and get 97.5%. If you were just doing what we did up here in the chart, you would say, oh, that's just going to be 1 minus, let's see, 2.35 and that 0.15 there, and that would also get you 97.5%. Whatever way works for you is fine. Okay? I tend to see things very visually, and so that's why I kind of do it that way. Is a young woman with a height of 62 inches unusually short? Justify your answer. Well, 62 inches is here. Okay, is that unusually short? She's at 1 standard deviation. Okay, and so the answer here is not unusually short. Why? What percentage, or what percentile is she at? Not unusually short since 16% of women her age are shorter. Okay. Can you see? Yeah, you can. That's it. Ta-da. So with that being said, we will finish up the chapter tomorrow. We're going to talk about exactly how likely things are. We're going to kind of play around with this idea down here a little bit. All right. We'll see you then. Talk to you later.